Let's take a look at example 8. Example 8 is basically really a domain question in disguise. So why is example 8 a domain question in disguise? When I look at this function, it says state the intervals over which the function is continuous. When I look at this function right here, this is a rational function. So this is really just a domain question. You want to know what's the domain of this function. And when you're calculating the domain, there's two things that can go wrong. The first is a negative under the square root. The second is 0 in the denominator. This is a rational function, so there are no square roots at all. So we're really looking at the denominator being equal to 0. So you would set the denominator here equal to 0. How would you solve this? You'd factor it. Oh, yes. Right. Is anyone tempted to do this? Are you tempted to go x squared equal to negative 2x, and then you cancel the x's, you get x equal to negative 2? Why is this dangerous, Rocco? Do you know why? It's the issue is that we're actually missing a root. Okay, so I have tons of students that do this and then they get it half right because there's 2 points where the denominator is equal to 0. So I'm going to follow Logan's suggestion, and instead of moving it over to the other side and trying to solve it algebraically, I'm going to factor it. And this is the preferred method. So you're going to factor as x times x plus 2. This gives you 2 zero factors, right? So you got x equal to 0 is one zero factor, and x plus 2 equal to 0 is the second zero factor. And then this means that x is equal to negative 2. So I think what we really want to do is, these are points that are bad. These are points you want to throw away. So I'm going to turn this into not equal to. These are all the things we don't want x to be equal to. Okay. So most students would take this and they would be like, oh, okay, I'll just leave it like this. But they're asking us to state the intervals. So what we want to do is we want to write this in interval notation. So if you were to draw a picture, it's almost like you have, this is your real line. Here's 0, here's 2. You want to put an open circle at 0, an open circle at 2, and then you want everything else. So you want all this stuff. Okay. So the way that we write this in interval notation is we go from negative infinity to 0. The U means union. 0 to 2, another U means union. You're right. Thank you. For sure, 100%. Maybe fix this. Negative 2, 0, negative 2, negative 2, 0, and then 0 to positive infinity. So this is our real answer right here. And I wouldn't highlight these. It's just like work on the way. Does that make sense to everybody? So sometimes people mix up union and intersection. When I explain it to my Stat 50 students, you can think of a union as like, you know, when people get married, they call it like a union. And then like, you know, when you get married and you move in together, like you take all of your stuff and it's joined together, you know? So like if I have a TV and my wife has a stereo, you know, she also has a TV, now we have 2 TVs, right? So union means you include everything that both people have. Well, I don't have a motorcycle. My wife doesn't have a motorcycle either. So the motorcycle would not be in the union. So like the motorcycle is like the point negative 2 here. That's what I don't have. $1 million, I don't have $1 million. My wife doesn't have $1 million. That's the 0, no. Intersection is like overlap. So intersection means it's in both. So if you think of like, here's Bonnie, and then here's Colorado, Chick-fil-A's in the corner right there. When you're standing right in the middle of the intersection, are you on Colorado? Yes. Are you on Bonnie? Yes, you're literally standing in the middle of the road. It's the overlap of the two streets. Just so you know, okay. Example 9 is the one that I really wanted to talk about, but example 8 is sort of like a good, I guess, warm up for it. So in this case, you want to state the intervals over which this function, h of x equal to the square root of 9 minus x squared, is continuous. So for this guy, this function has a radical, has a square root. And when they don't put a little number over here, this little number right here is called the index. So like if you're talking about the cube root, there'd be a 3. If you talk about the fourth root, there'd be a 4. If there's nothing there, it's assumed to be the square root. So don't put the 2 in, but I'm telling you, it's like the 2 is implied there. And the key thing is that this 2 is even. So when this guy is even, that's when you worry about having a negative under there. So what we really need to do is we really need to figure out when is 9 minus x squared greater than or equal to 0 if we want to find the domain. Okay. And just like we did before, I'm going to factor the left-hand side. So this is going to be, you recognize this shape? What is it? That's right. Is it a sum of two squares?
Difference between two squares.
Difference of two squares. Difference of two squares. Right. Okay. So we know how that factors, right? A squared minus b squared is equal to a plus b, a minus b. So this is like 3 plus x, 3 minus x. We have 2 zero factors right here. So we know that's from the first zero factor, 3 plus x equal to 0. That tells us, that tells us that x is equal to -3. If we have 3 minus x is equal to 0, that tells us x is equal to 3. And the way that we're not done yet, this is the places where it crosses the axis. So I want to go over a couple different methods here. So let's do it like this. It's supposed to be straight, but I won't worry about it. The first method is using test points. This is the method that students like. Okay. So how does test points work? You're going to draw a little number line. You got a 3 here, a -3 here, and you got a 3 here. And then what you can do is you can pick a point less than -3. Pick any point you like. Like you can come over here, you can pick like a -5. And then you plug -5 into this expression. And I'm going to get 9 minus 25. That's going to be a negative number, right? So then we're just testing to see the sign. So it's negative over here. Does that make sense? What point would you pick for the middle? I think there's an obvious best choice. Zero, I think, is the obvious best choice. I love evaluating at 0 because it's easy. So you plug a 0 into this guy. What are you going to get? You're going to get 9. 9 is positive. Does that make sense? Then you could, it's like a 0. And then the second thing, last thing you can do is you could plug up 5 in. You plug a 5 in there, it's still going to be negative, right? going to be 9 minus 25. It's a negative number, so it's negative. So using this test point method, if I want to keep all the points where it's greater than or equal to 0, I hope you could see that it's going to be this middle interval right here. And then the question becomes, do you want to include -3 and 3 or not include it? And the answer in this case is we want to include it because of this equal sign. So we're going to write our interval to be -3 to 3. But because we want to include the numbers, we put square brackets instead of round brackets. And that's going to be our answer. Does that make sense to everybody? Any questions? The third method I want to show you, this is preferred by me, but not necessarily for this section. It's more in preparation for chapter 3, which is more towards the end of the course, is I like to create a table of factors. So I'm going to show this to you again in the future, but I'm just demonstrating now. What I'm going to do first is I'm going to create this table like this. And I'm going to take my domain and chop it up into 3 pieces. So the 3 pieces come from finding these zeros right here. So when I chop my domain up into 3 pieces, it's going to go from -infinity to -3. That's the first piece. It's going to go from -3 to 3. That's the second piece. And the third piece is going to be from 3 to +infinity. So all I did is take my domain, I cut it up into the different pieces according to the zeros that I found over here. That makes sense to everybody? Then I want to write each of the factors down. So my first factor is 3 plus x. My second factor is 3 minus x. And then I'm going to compare the signs, and I'm going to combine the signs to get my actual thing down here. So I hope you guys all recognize that this object right here is a line. It's a line sloping upwards or sloping downwards. How do you know? What is the slope? 1. So the slope is 1, it's going up. Where does it cross the axis? X-axis, sorry, x-axis. Crosses the x-axis at -3 because that's what makes it 0. So it's like almost like this is the point right here where it crosses the axis. And it's going up. So it crosses the axis at -3 and it's going up. That means it's positive on this side, it's negative on that side. Does that make sense? What about this guy right here? What's the slope of this guy? -1. So now it's going downwards. Where does it cross? Crosses at 3. So now I'm right here, it's going downwards. That means it's going to be negative on this side, it's going to be positive on this side. So we have a table of signs. Now, when you combine these guys, negative times positive is negative, positive times positive is positive, positive times negative is negative. So because we're only caring about where it's not negative, this is going to be from -3 to 3. I don't mind if it's 0, so I'm going to include the 2 endpoints. So that's the second way that we could solve this type of problem. Same answer. So students like doing this. Usually I've found I like doing this, but for reasons you'll see in the future. Like right now, I think the first way is easier. But later on, we want to graph like, we want to create multiple tables like this. When you have like many factors, it's kind of easier to look at it this way. Okay. Any questions?